right. Yeah. Well, we sure appreciate your time, Merrill. Merrill's been a friend of SFAS for quite a while, I think. I think one of the first phono stage shootouts we had, I don't know when that was, probably 6 or 7 years ago. Merrill's Jen's phono stage won that shootout. He's a excellent engineer, and he's got some new amplifier design using the gallium nitride. So really appreciate you coming on, and look forward to hearing what you have to say.
Sure. Is it me now?
Yep.
Okay. You'll have to my first time presenting on Zoom, so everybody excuse me if I miss anything. Or if I don't see a question, you guys can chime in. I'm going to do this in two parts. The first part will be the business presentation. So it's still about amplifiers and so on, but more about why I did it. The second part, I'm going to dive into the different topologies, the different classes, the issues with each one of them, the pros and cons, and then dive into some of the very high level circuit and some of the detailed functions of, some of the drawbacks and pros and cons again of each type of topology. And then I'll finish off with some of the very, very unique things we've done to come out with our new line of amplifiers, and they'll be all very technical. So I welcome any questions in that, and hopefully it won't get. Hopefully I'll be able to keep it interesting, so you'll be able to stay on. But if anybody falls asleep, put your mic on mute so we don't hear your snores. So with that, Leslie asked me to just go over some of the COVID business environment that I'm sitting in from on the East Coast, at least. Early, I was actually in Seattle presenting to the Seattle Audio Society when COVID broke out. I was in Seattle, it became a hotspot. So I landed on Thursday, and it was a bustling city. And on Friday night or Saturday morning, the hotel had gone from a full hotel to 3 people. So it just died overnight. I took the overnight flight back to New Jersey. But that's when it all started. And what do you call this? Although there was a lot of interest at that time, it picked up. It seemed like there was also some reluctance, and then eventually it came, sort of a full circle, and it slowed down tremendously. Not just the people, but I think everybody is paying attention to what do I do at home, what do I do at work, how do I do this? So everything just changed. And from a manufacturer, we were having to deal with all the shows that we had signed up for, didn't sign up for, trying to decide what we do, whether we get our money back, whether you don't. Some of the organizers were very good, some were not so good, and some were just downright terrible. So it was very interesting in we had our minds all centered around that. And then the vendors started to hit. So they started to drop from working 5 days a week to 3 days a week. Because their business fell. And so, although I still needed supplies, I wasn't getting them as quickly. The lead time was taking much longer. And then shipping started to go crazy as well. So you'll expect something on Monday, it won't show up till Friday, and just all sorts of different things like that. Some people working 3 days a week. So if you ship something on Thursday and arrives on Friday, well, nobody's there till Tuesday. So it just sits there the whole week. So we had one delay after another with that, with production, with dealing with vendors. Customers had customers sort of went away on the high end, but on the low end, it got busier than ever. So folks like ISO Acoustics, they couldn't ship their product fast enough. They couldn't make it fast enough even. It was just flying off the shelves. It was a lower ticket item. And then over time, that sort of settled. Everybody's at home. They finished listening to music, the albums, everything else. And then So now we are getting more orders than we can handle at this point. So it's just sort of gone all the other way back. I guess everybody settled down. They spent all the money on the low ticket items, or maybe they just sat back to evaluate the systems. There was certainly a lot of reading going on. We got a lot of emails, questions. Our newsletters were widely read. So we had a lot of that. We had isolated too. So all our groups, our testing had stopped. We usually get a lot of focus groups to listen to equipment. That completely stopped. So now we're starting back, and everything. I think now we're back to Amazon's taken off like a rocket. So I think that's sort of the model where it's trending, even at high end. It's trending in that direction. So we're seeing a lot of online sales, emails, phone calls, those kind of things. So that's where the business is at today. It's almost like Christmas, man. The last month we did what we did almost in 6 months prior to that. So it's very interesting in that respect. And from that point, I don't know where we will go forward, but I'm not doing any shows till 2022. Even though some of the shows are coming back, like Capital Audio Fest in Maryland, Washington, D.C. said they're going to have one in November next year. I'm not doing that. So 50% of the people are not doing, manufacturers that I talk to are not doing shows. And another 50% think they are, but they're not quite sure yet. So it's a wait and see on the others. But I have no plans to go anywhere till 2022. So we're all planning to do something else, and I don't know what that something else is. I think VPI got very creative that he goes to his house, not his house, but he has a show house. He goes there and he plays music every weekend or something, and he doesn't get a big audience, but he has enough views on Facebook. Disney called him to ask him how he's doing it and what he's doing. So there must be a fair audience on that, and he caught the attention of Disney. That's Matt Weisfall. And I'm trying to think of some of the other.
Merrill, we had him on a couple sessions ago. He was
okay. Yeah, he's still full of energy, and even though he's doing so much all at once.
Yeah.
So that was great.
Do you think the changes that you're seeing in how you distribute and show your products are going to be more permanent?
That has been our model. We've been very fussy about distributors or retailers. We got burnt a lot of times where they just sell to make profits and then they forget the customer after that. So we've been doing a direct sale as well as finding, I like the home-based retailers. They seem to be the best ones. And then very, very small retailers. So that has stayed the same. We do worldwide online business. So we ship to anywhere in the world. And so far, we're also on the sort of early adopters. The customers are early adopters, so they don't mind doing that online. I cover the shipping both ways if they don't like it, but so far no products come back, so that's a good thing for me. So I think this, for my model, I expect perhaps it'll be hard for speaker manufacturers to do that. Maybe the smaller guys might, the component guys might trend into that. So if PS Audio is going 100% online, they're killing all their retailers. Maybe there's probably some in between. If you follow the Amazon model, they bought Whole Foods. They have local stores. You go to New York, there's a massive Amazon store up there. So and then the Apple store, they do retail as well as online. So there's a balance somewhere in between that. I don't know exactly where that's at, but certainly somewhere between that. We get about 50% of our sales online, 50% of our sales through retailers. So we're smack in the middle of that. And I haven't seen it. It might spike in 1 month on one side, but over the course of time, it just balances out. So that's kind of where we're at.
Well, it's great to hear that your business is doing very well. Happy to hear that.
Thank you. Thank you. Yeah, I have a question later on, but I'll ask the question now is how do you make $1 million in audio? You spend 10 million.
Yeah. Yeah. I think that goes for wineries too.
Audio, all the audio companies, I say, always started with a labor of love, right? And then they expand, and sometimes they lose their way and sometimes they don't. But at this point, it's definitely still a labor of love. And somebody aptly put it, it's my vanity business. So,
Merrill, Dan had an interesting question. If you went all direct sales, would your prices change? If you just
no, they wouldn't. So the reason for that is direct sales. We do a huge amount of advertising, and then the shipping costs, the maintenance costs, and all that. If the retailer takes it, he most times has a local customer, and the retailer does the advertising. So the cost just shifts from one to the other. There's a few companies we are priced based on manufacturing cost. And we're not like many of the other companies. So there's some companies priced based on market demand, what the market will bear. So we don't have that kind of margin to say, okay, we can drop the price. I did start the concept and a line. I have it all registered, but I haven't come up with it for purely online. But that's a much lower ticket item. I think that's where it'll play really well, where we can keep the prices low, not go through retailers at all. Warranties are limited. So you on the lower ticket items, you can do all of that and then just do 100% online with a lower price. So there's a gap between. I had a product at 3,500. I dropped that because that you want to go bring that down to a lower price line. So the new price line I'm looking at is $2,000. Everything will be 2,000, maybe 2,500, but somewhere in that range and under, and that will be 100% direct with no in between. But also the product will be made for that price market as well. So that you're going into a volume product, but a lot less, hand holding, touching, and so on. If you look behind me, these are the Genesis speakers. So for the Genesis speakers, you can't plop them down and expect them to work. We measure everything. We have a line. We sit there in a line and we play probably about 25 tracks. It takes about 5 hours to set this.
Merrill, you're muted. Yeah, Merrill, you've been muted. Can you unmute yourself?
Here we go.
There we go. Yeah.
Okay. I don't know what happened there, but somebody has my mouse. So I was talking about the Genesis speakers. They do require about 7 hours of setup because they're so finely tuned, and it's not a fake setup. It's not we want to sell you the setup. So it's set up such that we take each piece of music that we know how it was recorded, and it's used to set up the speaker. So you have imaging that, for example, a shaker that moves from the top left behind the speaker all the way to the front bottom between the two speakers and moves up. And if you don't set the speaker up correctly, you'll get a flat image behind it or smack against the wall. You won't have that full three-dimensional image. Then we tune the bass. We have recorded a piano, every key from the bass note, from the bass all the way to the top treble. That's 4 octaves, and we play that to make sure that it's even across the whole spectrum. So that product is very hard to say we're going to do that direct and cut the price, or you don't need a retailer on that. You do need somebody to come up who's very good and can tell you how to set that up and all that. So that's my take on it. There's different markets, and my take is not the ultimate. There's so many other different ways of doing this, price wise and expertise wise and setup and so on. But that's kind of where it's at. But just to stress that point, the Genesis speakers, they priced this at $36,000. If you listen to it, this should be priced about $80,000-$90,000. They are so underpriced. So the whole setup process that I told you about, if you bought a $70,000 speaker, they will come to your house and set that up for you. or 80,000. So if you bought, you know, a Magico or something like that, they would do that. So that's the marketplace. Did I answer that question in a long-winded way?
No, that was excellent. There was another, Phil sent a question. Comment. It'd be interesting to get the speaker setup playlist.
Yes, if you go to the Genesis website, he actually has his document on how to set up the speakers, and you can use that to set up your speakers as well. It works for all the speakers. And you know, I had a few people listen, and they said, "Oh yeah, I have the voice travel." I said, "Your speakers are not balanced." And he went back, balance it. Oh my God, it's right in the middle now. So you know, so you go there, and they give you each track. They list the track, the producer of the track, and so you can go get all the tracks that way. But yeah, it's a very, very good setup. You know, Gary Coe is a very humble fellow, so he doesn't mind sharing all his stuff, and he loves to share. So take a look at that.
Okay, maybe we can send that out to everyone. And then Albert has a question. What's the technology in the Genesis? I think Albert wants to buy a pair.
So the reason I got so familiar with Genesis, the first time I sat down and I heard it, and Gary happened to be in the room. So I said, "Oh, you made the speakers?" I said, "Yeah." So I started talking to him, and he had an answer for everything. Not that he was the guy full of answers and trying to you know, snowball you or anything. He had studied every piece of what it would take to make a speaker. So any question I posed to him or challenge, he had studied it and gone through that. So this speaker, for example, has 7 drivers. So he has got all the drivers to smoothly cross over all at the same timbre and tone. And he has adjustments at the back. So I said, "You can't do adjustments because you move the phase out every." He said, "No, I did a pi filter, I did this, that, and the other, and I got the phase to stay the same, even as I adjust the volume of each driver. And the only driver you don't adjust is the mid-range, and everything works around it." And I asked him about the phase within the front. You know, he uses a servo for the bass. I said, "You know, if you do that, you're just using velocity. It doesn't work when you overextend." He said, "No, use acceleration." He knew everything. So everything, there's a 1,000 things he puts into this speaker that he's gone from testing each cone material to actually the capacitors. He buys 1,000 capacitors. And by the way, the capacitors that he buys, and the inductors, every one of them are custom built to his specifications. And he goes around to find the specific manufacturer to that. So very, very interesting fellow. He learned all the basics from Ani Nudel, because he bought the company from Ani. He didn't actually buy it from Ani Nudel. The bank foreclosed on Ani, and he happened to be banking with the same bank who called him up and said, "Hey, would you be interested in this?" And he said yes. So and he's another classic case of how do you make $1 million? Well, he spent $5 million over the course of 3 or 4 years just trying to get the company back up and running, and only because he liked the sound so much. But yeah, they're fabulous. So he's taken care of every issue you would expect to find in a speaker. So this would do 90% of everything that a special speaker would do. For example, the horns would give you a good voice. This would do 90% of that. The what do you call this? The German physics would have coherency from top to almost bottom. This has 90% of that. Even with the 7 drivers, when we play that piano scale going from the low bass 4 octaves, you can't tell between the keys which which drivers play. You absolutely cannot tell. That's how good it is. So anyway, so that's enough of that. So,
yeah. Okay. Let's talk about your products.
okay.
So I mean to get.
I get excited with good sounds. So,
yeah. Well, so do we.
All right, I'll try to keep my face in here. I got 2 screens, so I'll be going back and forth on the screens. So I hope you don't mind if I look away a bit. Let's see, I'm going to put everybody on one side. All right, so let's start. So my name is Merrill Wettasinghe. I'm with Merrill Audio. I started the company in 2012, and I've been plodding along every year, you know, with all the different issues, problems, and all that. But I've managed to just keep going. And I think a lot of time I spend too much time on research and not enough on the marketing side. So I'm trying to to sort of balance that out a little bit. But I have a ton of products which I really enjoy making. And it takes a little while to come out because once I finish making it, it's the engineer's nightmare. We keep saying, oh, maybe I should do that. Maybe I should do that. Maybe I should do that. And then it just sits there waiting for the next piece. So I'm trying to rein myself in on that. And in this talk, if I get too far, one of you guys stop me and say, okay, move on. So, all right, so let's start with this. Yeah, who wants to listen to technology? Technology talks to me. You listen to music.
Merrill, I think you need to share your screen again, right?
Oh, it went off?
You're unshared, so.
Oh,
yeah.
that's terrible.
Yeah, so just share again, and then your presentation will come up.
Let's see.
There you go.
Okay.
Oh, for a second ago, and then it went off. Oh,
It shared?
Well, it pops on for a second, but then it.
Oh, the screen is not shared. Okay.
Yeah, you have to share your screen so we can
How's
see.
that?
Yep, there we are. Good
Okay.
job.
All right. I'm going to try this. Hopefully nothing breaks. Okay. Wait a second. All right. Oh. All right, we have a technical issue.
It looks, we can see it.
This is what I wanted. Yeah.
Oh, okay.
Yeah. So a bit about myself. So I enjoy music. I studied music. I played the classical piano for 8 years. I studied theory along with that. I don't remember a whole lot of theory right now, but I do enjoy playing the piano. So I play that a lot. And even though my fingers are stiff, so I stumble all over the keys, but it's just a lot of fun. It's also relaxing and it engages me. And you know, so listening to music for me is like playing the piano. It's just part of the pleasure that I get. I have a Bachelor of Science in Electronic Engineering, and that's some credibility, I guess. And then I got an MBA so I could sound like a business person, which I still don't, but it was fun to say that. And I started with electronics when I was about 7 years old. It fascinated me, and then I started building circuits when I was about 10. All the audio circuits sounded really bad, but I made everybody listen anyway. So, and then I did win all the science fairs, which funded a lot of my activities. So that was kind of fun as well. And then I used all the gadgets to tease all the teachers in my school, which is interesting. I like music as you might as well. So dancing, you know, you kind of you play something and you can't help but tap your feet or shake your head or move your hips to the music. One of my favorites is Hernando's Hideaway. And if you look this up, he recorded the LP in 1958, unedited. There's no editing. The dynamics on this are fabulous, and it's a Latin piece of music. So the brass on that will come through. You just listen to that, your hair will stand. It's just an amazing piece of music. But I listen to everything else. I listed a whole bunch here, but I also listen to some rap. You know, raps also has some interest. Not all of it. Some of it has some very interesting pieces there. But each person, you know, if you listen to Eva Cassidy, her pitch, her range is just astounding. Aretha Franklin, I don't know if you watched the video of her recording in the church in LA. They finally released that. That's just stunning to watch her go from this quiet lady to just singing, and it's just fantastic. So, and each one of these, you know, there's a zillion composers out there. They all have fascinating places. So audio systems take you into that place where you engage with the musicians. You can drift into their world and almost be like you're there with them. So that's my enjoyment on this, and that's why my strive is to get into this reproduction piece that gets me to where the musicians are. And of course, it's very, very low in calories, so that's excellent for me. I like that. So the mission of Merrill Audio. So I have to differentiate this. My nephew said, you know, I play the bass guitar. Why don't you make an amplifier for me? So I'm in the business of music reproduction, not music creation. So the parameters that are important for me are the accuracy and immediacy. So they sort of go hand in hand. You want something to come out to be immediate. If you hear live music, even if it's in a different room, you can tell immediately because of the immediacy of it. So to follow that rise in any kind of note, whether it's on the violin, a voice, or a piano or a drum, you need the accuracy to follow it and not do anything else. So that's a that's utmost important. And then following down, you have to clean up the system to get the transparency, make sure there's no other artifacts that come from all these things. And then I'll get into on the technical side, micro details are killed by feedback. So as much as feedback, reduces distortion and noise, it also kills all the micro details. So the heavier the feedback, the worse that gets. And so I try to design systems without any feedback at all. And if there's anything in that's needed with feedback, I don't put that in the audio path. I put that on the side of the audio path. So that really helps with that. And of course, low noise and distortion, we spend a lot of time and a lot of energy on trying to get that down. And, we measure not just the noise in the audio range, but we measure it all the way out to 1 megahertz. So it's very important to identify the noise, and the noise leads to distortion. But a good circuit, won't distort to begin with. So if you take out the noise, distortion tends to go down a lot. What we avoid at all costs is mellow. Just try to sound mellow, and we're not interested in that, of course. We don't want to smooth music out. If it's badly recorded, it's badly recorded. That's how it was recorded. That's how it's played, and we're not going to smooth it out. So, and again, we don't want to favor music. I listen to all kinds of music, but when I go to different places, when I test my equipment out, everybody has different music, and all the groups, all the focused people listen to not just different music, but different levels as well. So it has to be able to play on all types of music, all types of equipment, and has to be void of any coloration. The room can add coloration. You can color it with your cables. You can color it with all sorts of other stuff. But my equipment, I don't want to put coloration in it. And you can choose your coloration outside people. So that's kind of where it's at. So Bill, the classic example I have is Bill Evans. Somebody told me, oh, I got this wonderful pair of cables. I got to listen to Bill Evans Trio, which one of the albums. And he said, well, this one track was horrible. You could hear all this distortion and vibrations and all that. And I was fascinated. I said, first, let me get a piece of music. Let me listen to that, then see what it is. And I was fascinated by the cables, that the cable was able to take out all this distortion. Well, I play the piano. So when I was listening to this piece, I knew exactly what was happening. There were two strings, C and G, the two notes, I should say, C and G. The strings inside the piano had either a piece of paper or something on it. And when you play that particular string, you hear that paper vibrate. And just those two strings, nothing else. He could have had a loose hammer or something else, but it was just a loose piece of debris inside the piano. So for me, it was recorded that way. You want to hear that, and you don't want to take that away. So that's I know I'm a niche player, and I feed a niche set of group of people, but that's kind of where I'm at right now. So along that path, I was looking at different things, and the gallium nitride transistor caught my attention in the research. It showed up as one of the things that was up and coming, and that was quite a couple of years ago. And so I started looking more and more into that and started playing with that. So the gallium nitride transistor, if you look at what the other materials have issues with, so silicon, whether it's a bipolar, a FET, or anything else, they have a higher on resistance. So when they're, because of that, they have much higher heat. When you run equipment hot, you tend to dry out your capacitors. All your components change over time, they, if you have a transformer, that will start to change. Resistors have different issues in them when it's not hot and when it's hot. So you can mitigate all that with more and more expensive components, but it still affects the equipment very badly. So heat was one of the big problems. I've been working with Class D for a little while, and MOSFETs are very slow. In fact, and some people like that because they're slow, but they have a very high capacitance as part of the MOSFET build. So there's a gate with a channel, and the gate basically creates that capacitance. And so it takes a while when you switch it, let's say you turn it off, it takes a while for that little capacitor in that to discharge. When you turn it on, it takes a little while for it to charge. And that adds an effect to the sound. And with Class D especially, it was having a lot of issues, which is why one of the big complaints of Class D was this thing called dead time. With tubes and bulbs, as they call it in some other countries, you heat the cathode, and then you hope the electrons flow across to the plate, and then you capture it and use the gate to control the flow of electrons. But if you look at electrons, they don't all go out all in line. They kind of go out in a cloud, like a flock of birds. And so there's a lot of birds in the middle, a little in the front, and a little at the back. So it's not very precise. You also have the heat issues down there. It has the air, as you would call it, because of the lingering start and end. So that didn't work for me as well. And so I ended up with gallium nitride, which seemed to have all the good as a material, it had all the good characteristics. And then FETs, when they turn on, versus bipolar transistors, that is, when they turn on, they have low impedance. When they turn off, they're very high impedance. So they are good for a switch. They work very well for that. And the GaN showed to be able to do that about 100 times better than the MOSFET, and had a very low impedance when it was on, which means the heat is very, very low. Since you're not running it steady, you're doing a pulse. If the pulse switches on and off really fast, you have almost no heat being generated because that pulse is that switch is so low. I mean, so fast. So that's why I started playing around with the gallium nitride transistors. As with everything, nothing's perfect. So gallium nitride has a lot of issues. First of all, it's actually complex. It's complex in the sense that there's other things you need to worry about, and you can't say it's a simple transistor and you plug it in as a transistor and off you go. It's not a plug and play, unfortunately. It works differently from a MOSFET, even though it's a FET as well. So you have to redesign around that. All the parameters are different. Requires a higher drive voltage. It's very to maintain the speed of it, because it's so fast. It is very sensitive to the printed circuit boards, to how it's assembled, to the parasitic inductance and capacitance all the way around it. So we had to worry a lot about that, and it cost a lot more. It's anywhere from 5 to 12 times more than a MOSFET. So it's something that would be significant in the cost of building it. And lastly, the cost of building the boards. We had to locate specific vendors that could handle the build of the boards. All of it had to be machine placed and machine watched. And then when the boards were done, we had to X-ray every board to make sure it's 100% perfect. If you have anything slightly out of place, you'd have a mini explosion. So, and the reason for that was the components were all about, you had to have everything placed with less than 0.1 of a millimeter off. So you could not have any drift. And that's why we X-rayed the boards. And the mini explosions would happen when we pumped the maximum current voltage through it. But that's what would happen. But we do that to make sure that the boards are good.
Hey, Merrill, where are your boards? Where are your boards manufactured? Where are you?
We have, they're up in Canada, actually. We have we found a very good company up in Canada. And they've been doing that now for 2 years for us. And we actually shifted all our production to them, all our boards. So they are phenomenal engineers. They find problems before I can. So I really enjoy working with them.
And is any of your product made in China?
Yes. So, well, the products are not made in China, but some of the pieces are made in China. You can't avoid that. So the PCBs, the printed circuit boards themselves, the first pass will be run at, well, even the first pass is run in China, but China now can do 12 layer boards without any issues. A lot of components come from China, and not just China. So you have China, Vietnam, Thailand, Malaysia. There's not much going on in India. They do great transformers, but other than that, it's not a whole lot going on there. But China's expertise is very high. Their quality control is very low. So while we might do some things where you have a repeatable process, the most sensitive parts, you'd have to have a very good quality control somewhere to take care of that. So yes, so we do have, the aluminum plates. We make the copper heat sinks. Those things are all made in China as well. So they are made there, and then they're brought back here, and we finish them locally. So everything's done.
So you assemble in the US?
We finish with the finish, everything's done in the US. The raw plates and the raw parts are made there. So that's it. And the rest, then the final, the plating, because one of the things we don't do is anodize the amplifiers. The anodize hardens the material. And so we do plating. So we actually plate it with copper and then with the final finish. And that gives you a better sound quality. And that's all done locally. So the polish, the plating, everything else is done locally. And of course, the final assembly. The next question is, a lot of people say, well, how did you do this? And so on, and so on, so on. I would love to say I did all this myself. And the sad part, or the happy part maybe, is I did not. I was the conductor of this. And I had a whole orchestra that was in front of me that each one of those people were very good with what they did. So I found, for example, the vendors on the PCB side, they helped me design the PCB. I found the instrument guys that I was buying instruments from. They helped me with the high frequency, the ripple, the spikes, the parasitic inductance and capacitance. We bought some very, very advanced software that we start to use. We also went around to everybody we could find that was willing to help, willing to engage, and we worked with them. So our components are also custom built. The transformers, we have to use a choke on the outside, so there's an inductor on the output stage. All Class Ds have to have that. And that we had to go find a specific vendor to do that. That happens to be a US vendor. And they helped us with that, with the whole design. They got materials. They won't tell us what it is, but they got the right material. And so our coils are custom wound specifically for the amplifier, and we have one part number with them, but they've been very good with us. So each one of those things we had to go find, first research the components. Once we decide on the component, then we find the vendor. Then once we get the vendor, then we have to put that together, assemble it, design it, because each component would have something in it that we would have to design around, prototype it. Then we bench test it to make sure it measured correctly. Once we measured correctly, then we'd go do the listening test. And the listening test was the most fun because you take it to somebody's house, you put it in a black box, and then you play it, and you do A/B. And usually the A/B is like you play a song, go back and forth, back and forth. But this was so much fun because the amplifiers, the moment it was plugged in, no matter how lacking of resolution the system was, you immediately could hear it. All we had to do was listen to make sure there's no artifacts. And then we had to select components. So we were selecting components. But right from the get-go, we knew we had something fabulous because you could hear it almost instantly. With the first 30 seconds of any type of music, you'd hear it right away. Anyway, so that took months, and then you repeat the process, and that took years. And so over time, I think we finished the prototype early 2017, and we ran into a lot of production problems with all the different vendors. And then we settled out about 2018. We came out with the first amplifier, and then now it's sort of smooth sailing. Now everything's sort of battled. We conquered, I should say, everything. So we're in good shape. Again, so one of the things, it's not why I decided to build a gallium nitride amplifier, it's why I decided to stay with Class D. So all the different classes have, in my view at least, have issues. So Class A was developed in 1906. It was invented in 1906. Class B in 1935. And then, the drawbacks of both of them are a lot of heat, because when they conduct, they're conducting in the middle of their impedance level, and heat produced is current times impedance. So especially Class A, it's always conducting in the middle of that voltage. So there's a huge amount of heat. With that, if you stay for the technical presentation, I'll show you there's a lot of not just inefficiencies, non-linearities that come out with that type of topologies. So my options were to reinvent Class A and B, put some more band-aids onto it, try to get it onto a linear curve. I could use some other classes. There's E, F, G, H, I is out there as well. Or I could try to take the Class D with the MOSFETs and try to do something with that. Or I would have to more or less shut down and go back to the drawing board and start from scratch to do a gallium nitride Class D amplifier. So I wanted to leap forward rather than inch forward, and so I decided to shut down and actually do that. So I don't know if you guys follow me, but I kind of lacked product for about 2 years. So that was when I was going through this phase of finishing up this gallium nitride amplifier. So also the chassis, I started off with the chassis in 2012, and I left it the same all the way through. But now then I finally got it out and changed that. Also, a little bit of ego, but I wanted the best. I wanted to say, okay, this is like the best. Even if it just became a trophy product, I wanted that out. So I sat down to do that. That's how I did that. And I think I asked you that question about $1 million already. So you have that. But it did take a lot of investment to come out with that design, that product, and everything that went around that. So I'm going to ship a payout. I promised Larry I'd ship a payout in November, probably late November, early December. But you can hear the feedback from everybody that we've heard, the focus groups as well as customers and reviewers and so on, that this is like nothing else they've ever heard. So the first thing they always say is the enormous amounts of micro detail. They're hearing everything in the music now, everything on the track, and no matter what system they have, they just hear. That's over and over again. We heard that. Other things that we found, this is a little more technical, but the damping factor is not that high. It's 4,000, but it still has a very large ability to absorb the back EMF. So damping factor sort of does an impedance calculation, but it doesn't calculate how much EMF is absorbed, and we have the ability to absorb that. Yes.
Jeff Cleta had a question. Were you the first to use the GaN transistors?
I was the first to use the gallium nitride for Class D. It was used for power and it was used for RF before me. So, did I answer your question? And I believe I was the first. I could be wrong, but in this capacity where we're at, I was the first. I mean, when I started designing it, the manufacturers of the transistor itself had prototypes in their labs, so they were playing with it. It was not a full production piece, but they had that. So I can't claim to be absolute number one, but I think I'm in the high-end audio industry. I certainly can claim that. So so we have the ability to absorb that. We also the sustained power is when you're having a transient. The transient is starting to rise up. A lot of times it starts to rise, and then systems peter out, and it starts to rise even slower and slower, and then it just goes away. And this is different from somebody who advertises, I can do 100 watts RMS. So the definition of 100 watts RMS is you do it at 50% power for 5 minutes, and that's not what we're interested in. We're not looking at sustained, just a standard run of power. We're looking at the transients, and that gives you the immediacy in the music. So that's what I'm talking about here. So most equipment will go, a couple of nanoseconds, maybe 10 nanoseconds or 50 milliseconds, 100 nanoseconds. So we can go into the milliseconds, and that for a transient is a long time. So the other thing we did was, it's very transparent, very revealing. If you heard the phono stage, a lot of that information was used to make sure that we get the low noise and the transparency, and also once the transparency came out, of course, it was revealing. I spoke about the tight bass. It's very low heat because it's a class D, but more so because the gallium nitride on the switch is so fast that it just doesn't generate any heat, almost no heat on the switch. And in audio, it's even less. It's made for RF frequencies in the gigahertz. So for audio, it's almost underworked at this point. And then so for the future, we're going to make smaller and smaller amps. We will compromise on some of the qualities and maybe even the sound for the smaller amps, but they'll come down in power and price. And then other things we're working on, like integrateds and so on. But that's where we look to go forward with this. So that's the end of the business side. Any questions on that? I don't know if I ran through it too fast or too slow or too much or too
What's
little.
what you mentioned smaller amps? What's the size and weight and cost?
Yeah, so the thought process behind this is, and I told a couple of people about this in 2013, and they all went off and did it. But active speakers are much better sounding than passive. If you have an active crossover versus a passive crossover. So the smaller amps are meant to power, you have multiple amps per speaker. So that's the intent of the smaller power amps or the smaller amps. So we'll have an amp maybe for the bass unit, which is not so critical to have, the actual texture of the tweeter. And that will be a lower price point. And then we'll have another amp for the mid-range and the tweeter, which requires a lot less power. So you could have 50 watts or 100 watts, but still have all the immediacy that you need. And even if it went to a sustained, tweeters don't have a lot of sustained frequencies or require a lot of power. So that's where the smaller amps will go into. Price points. If you're buying multiple amps, we hope to bring, provide 2 or 3 amps in a box that would allow you to do that work in, let's say, $10,000 to $12,000. So they'd be actively crossing your speaker. We intend to provide the crossovers as well.
The ones that you're talking about now, the ones you have now, how big are they, and what is their?
Right now, so the biggest one is the power double. So it's 400 watts, goes to 800 watts, and then goes to 1600 watts. It will sustain that right across. The next one is 300, 600, and 1200 watts. And then the stereo version is 200, 400, and 800 watts. And the biggest amp we have is 38,000. That's 400, 800, 1600. The next one is it's the 116, and that's priced at 24,000, and the stereo is priced at 16,000.
And what is it that you're sending to Larry? What is he?
I'm sending him the 116s, the Element 116s. It is a I call it a shop version of it. So the chassis won't be the fully finished version of it, but the base will be different, but everything else will be the same. Okay, good. Any other questions?
Oh, and how heavy are they?
Oh, the weight. So
It's something that I personally care about.
no, of course. The 118s 65 pounds, 55 pounds each. The 114s 45 pounds each, and the 114, which is the stereo version, that is also 40 pounds. That's closer to 116, but it's 2-in-1, so it's 40 pounds. So that's what it is.
Larry, you'll let us know when you get them so that we can come over.
Exactly.
Yeah, well, hopefully, yeah. If you guys want, you can take it around and share and listen to all your different systems with that. So yeah, you guys know me by now. I don't put a on-off switch on all my equipment. It actually does annoy the sound, and it annoys me, so I don't do that. But that's easy enough. You just pull the plug and off you go.
Well, these are essentially Class D, so what's their power draw at idle anyway? Not much?
Yeah, 20 watts. Yeah,
Yeah.
you leave it on. All my equipment's meant to be left on all the time. So.
And Larry, Albert was asking if any of the gallium nitrides are in your gens. I don't think so. The gens came out before the gallium nitrides, correct?
Yeah, so gallium nitride is, they're still all discrete, and they made towards the power side. You can use them on a linear, on a different linear scale, but they're still not made for that. They're meant to be, the reason for that is cost, and they're just not made to be a low signal device. So that won't be out for a while. The companies, tons of them are coming out with gallium nitride transistors, but they're simply all focused on power, whether it's power supplies or radio transmitters, or the big market is 5G, all the wireless transmitters. So everybody's focused on the wireless transmitters right now because the whole world is building that out. I am coming out with a gallium nitride power supply to replace the ones in the old Veritas. So it'll be a drop-in replacement for the Hypex power supply, but that will use the gallium nitride transistor. Other questions?
Yeah, somebody asked about the gens phono stage and how well it works with moving coil cartridges.
It was built for low output moving coil, so designed for 1 millivolt output and 20 ohms or somewhere in that range of cartridges. So that's what that's the forte. It will work up to I'm sorry, 0.2 millivolts. It will work up to I think up to 5 millivolts, but the output, you need a preamplifier to handle the output. So the output of the yens will go up to 24 volts. So the higher the cartridge output, the higher the output voltage. So we can handle the output of the cartridge, but most preamplifiers cannot. So it's a different issue there. But yeah, it was made for very low output moving coil. It was designed for that. I did put in a few switches so that you can drop the gain, so that you can allow some preamplifiers to work with it for the higher output. I think Grado came out with a moving iron that was quite high, 0.9 millivolts. So I dropped the gain to accommodate that as well. Any other questions on that?
There were a couple questions I forwarded to you. One was from Gary Anderson at the New Jersey Club.
Right.
Let's see.
Las Vegas, yeah. So the tape-head preamplifiers, yeah. I did the tape-head preamplifier as a trophy piece. And everybody started to like it. And so I built the next one, which was another level up because they wanted this feature and that feature, and I put that in. Then I built the next one. So it's taken up a life of its own right now. The way we designed it was it doesn't care what the head impedance is. So between the head impedance and the cable capacitance, you can have it will accept just about anything. Most critical, I won't say critical, but the cable capacitance can go up to 290 picofarads. So if you find a cable with say 25 picofarads, you're looking at about 6 feet of cable before you start to hit that limit. Did I say that correctly? Yeah, 25, 4, 8. No, you're looking at about 12 feet of cable before you start hitting them. So that's one of the features there. So we don't have anything that says, oh, load your head up, your head this way, that way, anything else. It will work with everything. And that was one of the nice features. The second one we did was it takes care of every speed, 3.7 IPS all the way up to 30 IPS. And it will handle every EQ. So NAB, IEC, and then the AES IEC2, which is the 30 IPS version of the EQ. So do all those different EQs. Somebody asked me for, they want to, older tapes, they lose the high frequencies. So they wanted a high frequency adjustment. So it took a while, we put that in. And the reason ours is special is even though we have all that EQ and even the high frequency EQ, none of the equalization is done in the direct audio path. So the audio doesn't travel, the direct audio path doesn't actually travel through any capacitors. So that's one of our nice things that we did. And then Bernie Grummer was making some tapes. He's taking a bunch of masters and he's cutting 100 tapes from those masters. So it'll be a dub from a direct master, not a production master, but an actual master itself. And so he wanted to use, not him, but his crew was interested in using this tape head preamp, but they wanted specific EQs. Bernie's studio does an EQ at 50 hertz, 100 hertz, and 10 kilohertz. And we only had it at 10 kilohertz. So we're coming out another version for them that has all of that and a dual output. So we now have 3 out there. One's called the Master, one's called the Master Trident with 3 inputs. And the next one will be the Pro with 2 inputs, 4 inputs, 2 outputs, and all the EQs that you can think of. So that's the tape. And yes, it does, compared to any other old electronics or even other tape head preamps, it certainly does have our signature lack of sound. So it's clean, fast, and just very enjoyable. Any other questions on the tape head preamp? Yeah, it's a small, very small niche group of folks. Yeah, kind of fun. So with that, shall I start the technical presentation then?
Oh, there was one more question from Dan. Do you foresee a sub $10,000 Merrill GAN amp or pair of monos?
Yes, yes. So I want to bring that into the other company I called. It's called Bastard Audio. And I called it that because everybody's going to hate that company because it will.
Bastard, is that what you said?
Yes, that's right.
Okay, got it.
So that will carry all these low-end items. It will have no frills at all whatsoever. So it'll be plain boxes. It'll only be sold direct. It'll have very little advertising. And we decided to go with names of all the different bastards in the world. So the first preamp will be called Jon Snow from the Game of Thrones. And the Grado, John Chen from Grado was helping me out. He said, yeah, did you know that the English names, they are son of bastard this and son of bastard that. So we came out a whole list of names, and then my daughter started helping me on that. So every name will be named after a specific bastard somewhere. I mean, every product will be named that. But yeah, so we'll have monoblocks because of the chassis size, because the chassis will be kept very small for shipping costs. And so there'll be monoblocks, but yes, they'll be in there. It's about a year out, so don't hold your breath.
Don Naples wanted to know about the other 3 phono stages that are talked about coming soon on your website. Will they be?
Yes.
about a year away too?
No. So both of them, we finished the design, finished all the testing and all that. I'm working on getting all the Bluetooth paraphernalia all done, and that's been holding me back. And so the high end of the phono stage will have the loading. First of all, the input will be any kind of input, so it won't be called a moving coil or moving magnet. It'll be a moving anything you want. And it'll take an input from 0.1 millivolts to anything you want as well. And then the loading will also have zero capacitance, or we can go up to 450 picofarads in capacitance. And then the loading impedance will be from 0 to 100K. On top of that, we'll have about 5 different curves, prominent curves, that is, that you can play with. If you think yours was recorded on Decca, you'll have, this Decca curve to play with. Or if you want a little, you think your LPs are a little high. So that's the top end. And that has a special design on it with keeping in line with our previous designs that none of the EQ goes through the audio path. We're redoing the Yens, so we'll have a Yens 2, and the Yens 2 will have all the loading features as well. Both of them will have 4 inputs. Sorry, 3 inputs. Actually, it may be 4 inputs. I have to go take a look and see. So you can select any one of the, so you have multiple inputs on that. And then the lowest end will be a cheaper version of that. They'll have 1 input, 1 output, and we will sacrifice a little bit on the sound quality and so on. So that I anticipate coming at a low price of $9,000, which is still a high price for some, but that will be our low side. So it'll be 9, I think 17, and then 25.
And the new Yens will have single-ended inputs only still?
No, it'll all be balanced. Everything will be balanced. Yeah. So, one way. So balanced in, balanced out. You can take any turntable and convert it to balance as well as convert it into single-ended. But if you look at a cartridge, it's built to be balanced in the first place. So that's the problem with the balance is some of the manufacturers wire the tone knobs incorrectly. So you might get, we're going to have to deal with a lot of hum issues. If they don't wire the tone knobs correctly, that's one of the problems. Any other questions?
No, I think we're good.
All right. So to the next part, this part I like more than the first part because it's all the technical stuff. And I like that. So can you see the full screen? Yep. Okay.
I can see.
No no's means a yes. So, why is a Class A amplifier good? And that's a sort of a rhetorical question. It's a tongue-in-cheek question more than anything else. Amplifiers were named in the order that they were in the topology was invented. So Class A is not the best. It was just invented first. And that's why it's called Class A. Then they invented Class B. So then Class B was invented second. So they said, let's call it Class B. And then Class C and Class D. So Class D does not mean digital. It just means it was fourth in the line of invention. Then we had E and F, G, and H. So if you look at the Valier, they're using a H, on top of a G, I think. And they're just variations of Class D, where you vary the power supply on top of varying your output. So you're trying to play with 2 sides as one. Interestingly enough, Roger Sanders builds his Class B amplifiers with a Class H voltage control. So that's quite a combination there, but that's a good combination. It keeps his amplifier cool. So that's the name of classes. So sequentially, we look at the timeline. The vacuum tube, Class A was actually invented for the vacuum tube. The vacuum tube was invented in 1904, and then Dr. Forrest said, well, how do I put this to use? And invented the Class A topology, and so he got known for that. And then William Shockley invented the germanium. Germanium is a material, germanium-based transistor. Germanium is not a very nice material for transistors. Then, so Morris Tenenbaum invented, or first used silicon for the transistor. Silicon as a material wasn't invented, but he was the first guy to use that in 1954. And Class D was invented in 1955, but not widely used. It still had a lot of technical challenges. And then the MOSFET came along in 59. And interestingly, gallium nitride was invented in 1993 and was invented to bring the blue LED to market. And somebody was telling me a story. This guy knew Rondi and Dan D'Agostino personally and very well. And when the blue LED came out, Dan changed his amplifier to include a blue LED, and he sold tons of it because of the blue light. And there's a research paper showing that blue light is liked by everybody. And so they started putting blue lights in all the audio equipment and found that it sold more. So that was interesting, I thought. That's actually an indium gallium nitride, but it's gallium nitride material doped with indium to give you the blue light. Then gallium nitride as a commercial material started becoming available in 2000 or so. And then the transistor was done in 2009, and the first commercial transistor was generally available in 2012. So gallium nitride is fairly new in this whole scheme of things here. What I'm going to do is do a little bit of a course in electronic engineering 101 here, just to go through some of the topologies and some of the issues with Class D and how we solve that. So the blue box here is any device. You put an input signal, you get an output signal that's amplified. And the difference between the two is called gain. You put a power supply on the device, so you have the voltage, and the output signal is always within the realm of the power supply. Of course, you see the different symbols up there, the MOSFET, the gallium nitride transistor, the silicon carbide, and the bipolar, and so on. So this is what transistor, not just transistor, but all the different curves look like. So if you want to design something, first you got to pull out the curves of the device. So if you look at this, I don't know if you can see my cursor, but this on the left side is the JFET, MOSFET, and the pentode. So the pentode, that's a tube. They all have similar gain curves. On the right side, you see the input on that curve, and then the bottom is the output. On the next chart, I'll show you how that maps. So you put, let's say, an input of 2.6 millivolts, and you get an output of 10 volts. But you follow this curve for this particular device. Every device has their own curve. And you then do your design based on that. On the right chart, that's SIT, which Nelson Poss uses, triode, silicon carbide MOSFET. And you can see that the curves are very different from the other curves. So depending on which device you use, you'll get different types of curves. And if you look at the curves, you'll notice one thing: they're not linear. They're not linear going from left to right on the same color. They're not linear between each one. And that was one of the big issues. So if you want to operate linearly, you have to operate on a tiny, tiny, tiny portion of this, which means you have to multiply the number of transistors you have by a lot. So Dot Zeal was one of those famous people that they would match components. They'd buy 1,000 transistors and match all of that to be as close as possible to maybe 1%. And that's why the amps had such a good name. But that was one of the problems, was trying to get each transistor to match each other, and then the curves were not being the same. You couldn't operate in the wide range for every device. So that's one. So if you took the input here and you applied the input signal and you took a point on that curve, it would translate to some kind of output, and that you would call that the gain. And you would have to decide on a bias point or an operating point of that transistor where you were going to operate, so you can operate in the most linear portion of the curve as possible. If you operated in the nonlinear portion, you generate a lot of second order harmonics, which actually some people like. And I think even Nelson Poss had introduced something that would let you operate in that range to generate more second order harmonics. So That was one of the things that you know, was sort of a plaything in the audio industry for a little while. It still is, I think. So topologies. So class A is up here. If you look at the class A, you have a capacitor in the input and a capacitor in the output. You must have that because there's voltage. The transistor is biased to the middle of the voltage of your power supply, and it typically stays there. And you can't have a DC voltage going in or feeding out into the input, so you're gonna have capacitors there. And everybody knows capacitors have some kind of sound because they say, oh, use this, it's better than that, and so on, so on, so on. But that has a capacitor. Class B takes the half of the cycle and chops it up to the top piece of the transistor, and the bottom half of the cycle and chops it out and sends it to the bottom half of the transistor. So they still could be biased, and they have to be because transistors have a little bit of voltage before they actually fully turn on. And your input signal is split into top half and bottom half, and then it's joined again at the output, and you get your signal. There's crossover distortion, so you have to design around that. And you hear famously of a class AB design. The class AB design takes a class B and throws a class A on top of it to operate on a small portion, and for the majority of the portion, it operates in a class B environment. So that's topologies. I went over this earlier why I did not want to work with any of those topologies. So class D, you put an input signal into that. Modulator takes it and converts it from an analog signal to pulses. The width of the pulse will depend on where in that analog signal you are. The higher you are, the greater the pulse. So it has to keep the pulse wide. So the class D works like a tank. If you think of a tank of water and a spigot at the bottom, you fill the tank and a lot of water runs out. Say the spigot has unlimited capacity to run out. If it has a lot of water, you have a huge rush of water out. You have little water, less rush. So you fill the tank, you empty the tank, you fill the tank, you empty the tank. So class D works like that. It sends out the pulses, which is buckets of water filling the tank, and the inductor and capacitor out here smooth it out. So the water flow is very smooth. It's like a linear flow that comes out. So the ultimate output is linear. You don't see the pulses. But what happens is you have to make sure the pulse is long enough or short enough to fill or empty the tank according to the audio signal. So that's the trick in class D. So this is a big tank here. You can see more detail of it. One of the things we do is in class D, everybody says, why don't you operate at 1 megahertz? You're using gallium nitride. Once you do this, once you do that. The frequency of switching is not important. The time it takes to turn the pulse on and off, that is where the importance is. So you have to watch exactly where you turn it on, exactly where you turn it off. And if it takes a long time to turn on and off, that's the distortion that everybody complains about. So class D had a really bad rep for the dead time of where it takes the transistor to turn on or turn off. And that dead time, you weren't filling the tank or emptying the tank appropriately. You couldn't do anything at that time. You just had to sit and wait. So, and that dead time was quite a large chunk of music, time in context of music. So what you see here is you have the modulator. It comes to a gate driver because you have to have a special gate driver for the gallium nitride transistor. And then we have a logic to adjust the timing. We can adjust the timing down to 1 picosecond. That means we can adjust timing to about 10 megahertz of frequency. So that's how accurate we can get to give you precise audio measure, to give you an audio signal. We do all of this with zero feedback. There's absolutely no feedback in our system. If you look at a regular class D, here are all the issues. When you convert the analog audio signal to a pulse, you have quantization error. that is, when do you make that a pulse and when do you not make that a pulse? And there's a little bit of timing issues. But because of DACs, everybody knows digital very well. So this is no longer an issue with just about everybody else, and us, of course, but this is just not something that we have to worry about anymore. The dead time that I spoke about when the transistor turns on and off, if you have a device that cannot turn it off instantly in the context of audio between 20 and 20 kilohertz, then you're creating other types of distortion. And that dead time, most people try to deal with the dead time by providing feedback. They do more and more stages of feedback, different orders of feedback. They do feed forward, feed sideways, everything. That just changes the sound. It doesn't stop the problem. And yes, the Veritas did have that issue. The next one we have is the when the transistor turns on and off with the MOSFETs, you have this issue where it has a discharge, and the inductor and capacitor have a discharge too. And between all of them, they create bus pumping. So the power supply starts to rise above where it should be and go down below where it should be, and it becomes oscillations that you can't control. So that's also well taken care of. But in gallium nitride, that's not an issue. And then the devices, inductors and capacitors, they're all nonlinear. I'm sorry, I take that back. The capacitors operate linearly to a certain point, then they become nonlinear, where the parasitics take over. So you have to operate a capacitor in the linear portion. The inductors have a hysteresis curve. All transformers, all inductors have hysteresis. When you run a current through it, it takes a little while to charge up and generate the magnetic flux. And then when you reduce the current, it takes a little while to discharge, but it retains some of the magnetism. So you have to actually apply a negative charge to reduce that magnetism to zero. So that's called a hysteresis of a inductor. Some people like transformer volume controls, but they also have the hysteresis problem. So hysteresis was a big problem which Class D we had to deal with. So the first thing we did was we found a vendor among many vendors that will work with us. If we use the right material, we can, it's called soft metals or soft materials, we can bring the hysteresis curve to be very, very narrow. So the up and the down is very narrow. The next thing we did was we operated within a very narrow region of that inductor. So the inductor is actually overbuilt. And we operate in a tiny portion of that so that we're nowhere close to any of the nonlinear sections or the saturation points. And then, of course, it's custom made for us. So once we have that, it's always made the same way for us, and we can dictate how we want it. Then we go back to our timing. Don't forget, we can adjust our timing down to 1 picosecond. We adjust our timing so we know that hysteresis curve is coming in or out, and we adjust our timing so that we take care of that. So that's how we got around the inductor issue. And the PCB, the printed circuit board itself, if two traces are next to each other, you have an inductance, you have a capacitance. You can't not get around it. If one trace is on top of the other, even if the bottom is a ground trace, there is a capacitance. You can't get around it. There is an impedance that you can watch. So we had to watch all of that because that causes ringing. We used 6-layer boards, and it was designed over and over and over again to remove all the ringing and all the overshoot and undershoot, and bring it down so it followed that square wave. So our rise time, overshoot and ring, that whole piece down there is less than 10 nanoseconds. So that's actually quite phenomenal. So that's what we did with that. So most of the problems with audio gear are around fast transients. If you don't have fast transients, you like mellow music and all that, these are not issues. But if something rises really fast, it spews out all sorts of things. It works on the next trace. It has a reflection. It creates EMF or EMI that you have to take care of, and it goes and spreads into all the other pieces. So fast transients were one of the big things they had to play with and make sure that we understood the reflections, the EMI, We didn't use any feed forward or feedback or any one of those things because it reduces micro detail, but that's a common way to handle all those parasitics. And then if you still insist on having a fast transient, you're now straining the power supply. When you have that transient, especially if it's a big transient, you will suck that power supply. It may not seem like much, but you will suck it, and the power supply will struggle to keep up. And then when you release it, it will say, "Oof," and then let this whole thing go. So you have all sorts of other problems that show up there. And so we had to make sure that when the power was needed, it was right next to where the power is actually needed and not somewhere else on the circuit board. So those were some of the things that we did. Of course, other, there's, I say other manufacturers, but this was typical ways of dealing with all these fast transients, feedback, slow down the signal, simply use slow semiconductors, it would just automatically slow it down. If you use a transformer, the input, it would slow the audio signal down enough that you won't have to deal with it later on. And some people would use a transformer, the output, to reduce, to sort of smooth out the ringing. So those are tricks, but they introduce other types of, distortions. And as I mentioned earlier, higher frequencies simply don't bring anything more other than exacerbating all the issues you already have. So the switch time is really what's the most important. So we did all of that. The hysteresis was designed in from the beginning and not as an afterthought. The dead time, again, from the beginning. We started with the 6-layer PCB. We went out to all the manufacturers, asked them how we should work this, help us out with that, all the different materials. We went through, we also use, I forgot to mention this, we have what's called a Llc Power Supply. It's not a new design, topology. Our design is, it's custom transformers in it. And we use the transformer as an inductor. So the output of the transformer is very specific. It has a very specific inductance that it's part of the whole circuit. So it's a tank circuit with 2 inductors in it. And of course, the biggest part, which I can't tell you about, is our proprietary modulator and our timing logic, where we can time it down to 1 picosecond. So that's the big part. And yeah, after all that, it sounds good. I'm very pleased, and our customers are very pleased as well. So that's where we're at. We got out a prototype in 2017. The 118 amplifier came out in 2018. Last year, we introduced 2 amplifiers. This year, we're introducing all our other products that have been sitting there while we were developing this. So we have the tape head preamp, which we had 3 of them. We'll have the Christine Mark II out, which is a new preamplifier, a new version of it. We'll have hopefully the lower end preamp, which is already done. We'll have tone controls, which we'll include into that. And we're looking at some of the future amplification improvements as well. So that's the end of this presentation. Any questions on that? Did I keep everybody here? It looks like some people are still here.
I got to say, your MBA paid off well if it allowed you to learn how to do this PowerPoint presentation.
Oh, well, that's a compliment.
Wasn't glitzy, but it was filled and easy to look at, and you followed it well. So,
oh, good.
So
I hope my amps are as good as the PowerPoint.
yeah,
Yeah.
with your knowledge of this design, is there any opportunity for you to make other amps for other manufacturers or sell them part of your design? Or
Yeah, I was thinking about that. So it's you can have co-opetition, and if you look at Hypex, they did exactly that, and nobody ended up the winner because they just went off to make more of the same, and then nobody could differentiate any product, and it just became a mass commodity without the attention to the fidelity of the sound. It became more a marketing ploy than oh, I got this, and so it should sound good, which it didn't. So that's the challenge there. I was thinking of making the amp, but not for other amplifier guys, but for speaker guys. Because as I mentioned earlier, the speakers should be active. If you can do an active speaker, the sound is amazing. So if you I don't know if you guys have heard any fully active systems. They're always just so much better than anything else. Even though they may not be linear, they may not have coherency, they have this, that, and the other. Once you take the crossover out, it just becomes so much nicer. So that's my thought. The short answer is no. I'm not going to make it for somebody else.
But
Yeah.
even if you take the crossover out, there's still a crossover in the speakers to make them active, right?
No, you can do yeah, true. So this is where all the other lighting. So we make a phono stage and we make a tape-head preamp where we don't put that in the active signal part. So there's a lot of ways to skin this cat, and we have some other ways as well that are all extremely good.
Any thoughts on making a active crossover for sale?
Yes.
Yeah.
Yes.
Good. Good.
Well, I was actually making it more for the for some other pieces, but yeah, it would be it would work very well with the speakers as well, so that would have an active crossover. But yes.
And
Merrill, this is Albert Dahl over here in San Francisco area. I'm looking, hey, good to see you there. Thanks for the presentation today. A lot of great ideas about amplifiers and everything. I'm looking at some new speakers that are actively crossed and amplified. These are the legacy speakers. Do you know anything about the amplifiers that Bill Duddleson is using in those?
No, I don't. I don't. I've lost touch with Bill. So, and my first pair of extreme audiophile speakers, I actually bought a custom pair from him years ago, and I thought his speakers were good as some set of speakers back then. I've heard his speakers in shows and all that, and I chatted with him a bit, but I don't know what amps he uses. I don't know if you came on or not. I was talking about the speakers behind you. Did you hear about the Genesis?
Oh yeah, I was interested in hearing about that too.
Yeah, so they're based up in Seattle. If you go up to Seattle, you can take a listen. And Gary's very hospitable. He's a very nice guy, so he'll be happy to show you around.
Well, thanks. Or is anyone else making improvements to their Class D amps like you are?
Yes, the short answer is yes, and they are either taking the old Class D with MOSFETs and like somebody just put out a paper saying, oh, we discovered hysteresis in the choke. They've been doing it for decades, and they just discovered that. And so we're doing this. So everybody's doing a little bit of band-aids on top of the Class D. And of course, some people are taking the gallium nitride and saying, oh, we're making a Class D gallium nitride transistor, and not using it as a gallium nitride transistor, using it as a regular Class D with a MOSFET. So that's all the so-called competition I've seen. Somebody might be in the lab developing something exactly like what I've done. I don't know.
Yeah.
Yeah.
Well, we look forward to getting to hear yours. It sounds like, no pun, that everyone likes it.
Yeah. Yes. You may have a flavor that it may not be a cup of tea, but otherwise, yes. So far, everybody's been quite wild with it. So I've been happy. I need to go market it more, and I think this year or next year I'll try to do that.
And I'll just ask one last quick question. The chassis are beautiful. Is the design of what looks like weights on the top of the chassis, is that for aesthetics or does it help in performance?
It's both, yes. So as much as I try to stop any ring in the chassis, audio signals must have electrical signals in it some way. I don't know how they do it, but the material of the chassis somehow affects what kind of quality sound you come out. So we wanted to make sure that any ring in the chassis would be damped. And so we were going to put the plates on the inside. Then somebody said, "Oh, sticking on the outside looks good," so we stuck it on the outside. And then we don't anodize this line of amplifiers because the anodizing hardens the material, and it again acts. If you have steel footers, which I used to use some time ago, so the steel runs a certain type of sound. If you put a piece of ebony underneath that, you get a different sound entirely. So all these things add. So I ended up with actually isoacoustics because they actually have the background of. Do you guys know Dave Morrison on isoacoustics? Yeah. Did he ever do a talk?
We haven't done that yet.
Oh, you should. He's a fascinating fellow. He worked for Canadian Broadcasting Corporation for something like 40 years. So he was there. He was the acoustics guy for them, setting up all the stages, doing everything. And he was annoyed with all the vibrations going through. So this is an outcome of his 40 years of working there. And the CBC, they have a research center that they allow anybody to go in and do measurements and all that. And so he went in there, and the shuttle sends the space shuttle sends their shuttle there to the CBC to measure the sound inside the shuttle. This is how good that center is. So he's done measurements with lasers on mirrors so that he can tell what the sound transmission is between different types of footers. And that's the science behind this. But anyway, regardless of that, it sounds really good with his footers. So I used that, the chassis material, the chassis damping, and then inside I have a little more damping as well.
We're looking forward to it. Thanks.
Oh, sure. Yeah.
So, Merrill, maybe you could turn off your sharing your PowerPoint now.
Oh, sure. Yeah.
That'd be good. And then I think you mentioned a little bit about power conditioning, power supply. Could you talk a little bit more about that?
Yeah. How do I turn off the sharing? The
It's at
PowerPoint.
the bottom of your screen. You
Uh-huh.
put your cursor down there and it says screen share. Just click on it and it'll run the screen share.
Okay. It doesn't say, it just gives me different screen options. It doesn't say don't share the screen.
Are you on an Apple?
No, I'm on a Windows.
Oh. So, yeah.
If it's green now, I think just click on it and then it will turn off.
Oh, okay.
Share screen. Just click there.
You are screen sharing. Oh, you just went somewhere else. Oh, here we go. Okay. How's that?
Yeah.
There you
what?
are.
Oh, good. Thank you. Somebody had a
Power
question somewhere
supplies.
else?
Power supplies.
What's that?
Power supplies.
Oh, yes. What was the question? I'm sorry.
Albert wanted to talk about power supplies.
Oh, power supplies, yeah.
Power conditioning and
Oh, power conditioning.
yeah.
Yes. So we the preamplifiers that we have, we do roughly about 5 stages of conditioning and filtering, and then within all the circuits, we're doing filtering and filtering and filtering and filtering. So power supplies, we're obsessive about power supplies, power lines, wires, down to the wires that we use. And we solder, we don't use plugs, we use solder. And even the solder, the technicians are trained on a specific way to solder it so that the solder is not making the connection. The wire is making a connection and the solder only holds the wire in place. So that's one of the aspects of it. The second one is that the power supply has to be able to deliver instantaneous power. So it has sort of a reserve, and it changes its power, its filtering, or its spigot, so to speak, according to the power requirements. And then we try to keep everything as close to where it's needed, as opposed to a centralized place. So that's kind of where what we do with power supplies. even though like the preamplifiers have an external power supply, we have another whole stage inside the unit itself to redo that whole power supply stage as well. Does that make sense?
Mhm.
Okay. So I have to make sure I make sense, but don't get too technical as well. So,
We love the technical.
oh. Anything else that I can answer for you or talk about, or just kind of?
Somebody asked much earlier about the gens is the only phono stage you have now, but the three others that are coming, can you talk a little bit about each of them briefly?
Yeah, sure. So the Yens will have a refresh, and it'll be the Yens 2, and then we'll have the Yens, the element Yens. So it'll be the series of amplifiers. It'll be the element series will follow that, and then we'll have a lower end with lesser sound quality, and that will be called the Kaylee. And that so they're all designed, some of them bench tested, and we'll just finish up some different areas on it. The main feature will be that they will be built for any type of cartridge, moving coil, moving magnet, moving iron, anything you want. It will have a capacitance from 0 to 450, so you can use it for moving coil or moving magnet or whatever you want again. And we'll have a loading impedance up to 100 kilo ohms. I'm sorry, 100,000 kilo ohms. The highest end will have multiple curves, Decker curves, and so on. Some people like that. It will also have 4 inputs and 2 outputs, and all of them will be balanced. For all the phono stages, it will all have balanced inputs, balanced outputs. The Yens, the second version, the Yens Mark II, I'm just going to make that with 3 inputs, and then the low end Kaylee will just have 1 input.
Merrill, Dan had a question. How'd you characterize the sound of these amps versus your earlier Hypex amp and other amps?
Yeah, so the quantification of that is 10 times as an order of magnitude better. The sound difference is very subjective, right? So I'll give you what I've heard back from people as subjective. It's hard for me to say, oh, it's wonderful, because everybody thinks their baby is the cutest in the world, right? So this is the feedback that we've got. First of all, the micro detail, they just hear things they've never heard before, and it's all presented without exaggeration. With the Hypex amps, you kind of get detail, but there's a little bit of stringiness to that information, and it's nowhere near as detailed. The bass, they hear much stronger lower bass, certainly much tighter, and that bleeds up into the voices and the violins and the strings and so on, because the attack is so much better than what they've heard before. But it's hard to just say the attack is better, because the tone and the timbre is also improved. The overall quality of sound is much more natural, is the word that they've all used. It's not just more natural than the Veritas, but more natural than anything else they compare it to, whether it's the Dot Zeal or anything else they have. So that's kind of where it's at. So we were I was just helping a friend who was a customer, is now a friend, and still a customer, but we took the Veritas and we said, let's buy he has the Element 118s. And I said, why don't we buy him your Kef blades? So we went in and the Christine preamp has dual outputs. So one output went to the 118s and the other output went to the D speaker. And from the D speaker, we sent it to the Veritas, to the bass unit. And we played around, we got it good, and we said, well, it sounds okay, but somebody said, let's see what it sounds like with the elements again on the full range. When we switched it back, the sound was so amazing that one amplifier could sound so much better than a bi-amp system. It was just, we were stunned. when I say we, the reason I tell a story, I was stunned myself. I honestly thought a bi-amp, even with the Veritas, would sound better. It didn't. So the characterization of the element series, of course, this was with the 118, is that it's about an order of magnitude 10 times better than the Veritas.
That's great. So because your application of the gallium nitrides is an order of magnitude better, do you foresee implementing gallium nitrides into your phonostages?
No, the gallium nitride is, we're replacing power. There was a gap in the requirements for power, and gallium nitride was a good fit for power. It's built for power, so we don't see that going lower down for the right now. We will see that coming out in maybe 5 years from now. That would be about the time frame when the first one will start to come out. Some people might play with it, but they're just built so differently. Power unit, you're operating at voltages that, many times that of a phonostage, which is micro detailed. So right now, it's like taking a Bugatti to drive in Manhattan. You just kill the Bugatti; it'll just never work. So that's kind of the best comparison I can provide.
Hey, Merrill, what's in your system now? What else do you have other than your amps? And...
you have the amps there. I'll see if I can turn this.
Nice.
I have the Christine, loan to me. That's the VPI.
You're facing away from. You're facing away from the microphone. We can't hear you. You're muted.
Hey, Merrill, can you unmute?
How's that?
There
Can you
you
hear me
go.
now? Okay.
Yes. Yeah.
Okay. So if you look at the system there, you see I have the Christine, I have the Jens, and the VPI turntable there with a VPI arm. So this was loaned to me by VPI. It is the magnetic Avenger reference. It has multiple arms. I haven't put the other arms up, but I use that to compare cartridges. I'm still using the Lyra, what's the lowest end of the Lyra, and that seems to work well for me. I play around with the Atlas, but not since there's always something happening. That's not a good cartridge to use, but I know what it sounds like. Behind that, you can see a tape deck. And below that, you can't see, but I have my prototype DACs sitting on the shelf and a couple of other pieces of component. And
Are you making DACs? You said a prototype DAC?
Yes. I actually have 2 DACs in development. They've been sitting on the shelf.
Okay.
Yeah. I like to play with this stuff, and then once I build it, I sort of lose interest in taking it to market. So one of the sad pieces that I have. So I have actually 2 DACs. One's a mini DAC and one's a high-end DAC, or medium DAC, I should say. I wanted to put the mini DAC in the preamplifiers, but I don't know if I'll do that or not. So that's kind of where it's at. But the DAC, so this is to compete with MLabs, but that's yet to be seen whether it'll how far it'll get in that range. So that's kind of where it's at.
That'll be a chip-based DAC?
It is. The short answer is yes. So there's a couple of things that we do to inside that, and part of it is reclocking all the signals and everything else. So that it's a bit more complex than just that. Yes. And chip-based actually is a tough question because everybody uses chips in that realm. If you mean it's a ladder DAC, no. The ladder DACs has too much phase issues. The phase runs all over the place and it's very hard to control. Even if you use lasers to trim your resistors, you still have a lot of phase issues.
We had on Happy Hour last night, we had an interesting discussion about DACs and how the technology is changing so quickly, we like DACs that we could actually just upgrade
Mhm.
opposed to buying new equipment every year. Is that something you're thinking about?
Yeah, if you build something that's upgradable, you have to do a lot of compromises. So some of these guys are using FPGAs. So the FPGA is a computer, but it's a program. It's hard programmed into the chip. What that means is your actual output is not as time deterministic as you would like. Now, for the most part, you can say that it's deterministic within a window, but the window in audio is big enough that it's not good. So, you have all those kind of compromises. If you use a CPLD, you're much better in time deterministic signals. And I don't know why people don't use CPLDs versus FPGAs. But that's a better way to go. It is smaller, it's not as complex, and you can't do as much. But you definitely could make a DAC out of a CPLD. However, that has some timing issues as well. So those are the trade-offs you have. If it's upgradable, then how upgradable and what is it that you're upgrading? Are you really upgrading it? Some people come out with, I'm oversampling. So my discussion with them is if you're oversampling, let's say you have the signal has a 1, then it has another 1 after that, and that's a 44 kilohertz. And now you're oversampling to, let's say, 192. What are you putting in the middle between those ones? Are you making information up to oversample? How are you oversampling, and what are you oversampling? So normal digital theory is when you oversample, you put in zeros. If you put in zeros, then you're softening the sound. You have a 1. Now you're having, if you oversample twice, you got 2 zeros in there, and then you're going back to 1. Your sound has got that much softer. So those are the problems with upgradable devices. I'm looking at faster and faster devices. As the speed goes up, it gets more time deterministic. And once it gets within the window of audio, then you can start to say, okay, now it's upgradable. So that's my long answer to your short question.